What's up, guys? West Coast Picks here. If you watch my Twitter feed, that's @ West Coast Picks, you'll probably have seen this pinning tray. And a lot of people have seen my CNC router before or heard it going in the background and stuff like that. And I had a lot of questions about it and had some people expressing interest of maybe them getting their own. So I thought I'd have this video about how I step-by-step create one of these pinning trays, what I've learned about these machines and how everything works, how it has to be set up and all that stuff. There's a bit of a learning curve with any kind of new piece of equipment, especially the technical stuff that I like. To me, that's half the fun, figuring out how a 3D printer works, figuring out how a CNC mill works, all that stuff. So I thought I'd show you guys what I learned, and while I do that, in the process of doing that, I'll show you how I step-by-step create one of these pinning trays. So this is just poplar. So you can see I got a bunch of them here. So far, I've made 3 and have etched 2 of them. So this bottom one is etched and this one is etched. And the reason I settled on this machine is because it actually came with the router and the laser itself. So I actually have both features in this one machine. It is actually a laser engraver and a CNC router. So you can get it just the router machine, or you can get it with the laser, or you can get it just the laser. This one actually came both. The model is the 1610, and what the 1610 stands for is that means 16 centimeters across by 10 centimeters high, and that is the available workspace that you have on this machine. There are different models, and the model numbers, that's what it means, how many centimeters length by height. So the reason I settled on this one is not only because it came with the laser and the CNC router, but also because it is the perfect size for what I need. I don't need anything bigger. These pinning trays are the perfect size. And you see a lot of people have these giant pinning trays on their desk, and it takes up their whole work area, and you don't really need anything bigger because you're just putting some pins and springs on it, maybe a tiny few little lock parts and a pair of tweezers or something. You don't need this giant thing on your desk that you can't even hold up to the camera to show off the pins. So to me, this was the perfect machine for what I needed, and that is to make pinning trays. Anyway, I thought I'd take you guys through everything I've learned about this machine, how everything works, the software and the design, and how put it all together. So first, about the machine, I told you the working diameters and stuff like that. You have to set it up for what you were using it for at the time. So right now, the first bit we're going to do is a router, and for that, you need to put the routing motor in there, which you basically just put it in the holder and clamp it down, and then plug it into the back of the board. It's not a problem. You need a blank board, and the size that I'm making mine, the exact same size, is 140 millimeter. That's actually 141 millimeter by 100 millimeter, and that is because the material I'm using, the board that I'm using, actually comes, just a nice big long hardwood board here, actually comes 140 millimeter wide. So I just cut it 100 millimeter sections, and then I have my board, my blank. So that's what I start with. I made these clamps, 3D printed these clamps to actually clamp on the edge of the board, so I can clamp it down on the surface there. Normally they just give you these wing nuts with these special bolts. These bolts go into the tracking there, and you would just use the washer and tighten it down on the wood itself. But I didn't like that, so I created these brackets that actually hold the board on either side, and then I strap it down to the platform. And that works really good for me. That is one upgrade I did, and another thing I did was created some tool holders here for all my milling bits and Allen keys on the other side. So basically that's it. Everything else is stock. like I said, we're going to start. This is a piece of poplar. It is 100 millimeter by 141 millimeter. So that's what we're going to start with. I'm going to clamp this up. I'm going to get it on the platform, clamp it on there, and set up the router bit, and I'll be back to show you what that looks like. Alright guys, I've got it set up here. You can see that I've got my 3D printed brackets holding the board down. The whole thing is screwed down. I have the router in the tool holder, and it is plugged into the board in the back. So everything from here is software. The hardware is set up. The routing bit I'm using right now is a 6 millimeter router bit. So it's actually just like a regular routing bit, but for a Dremel. So all Dremel bits will work with this machine. So everything's set up for the hardware. We're going to go over to the software portion, and I'm going to have to set my camera up in a way where you can see the screen. But I'll get that done, and I'll be right back. Alright guys, we're in the software that the machine came with. It's called ArtCam Pro by Delcam. And we are going to create our pinning tray here. This is the program where you model your object, and then you can actually convert it straight to G-code and then send it to the machine through a different program. So first thing we're going to do is create a model, and it's going to ask you for the size of this model. So our height and width are set up. I've already made this model once, so I guess it remembered it from last time. But we're going to go again from scratch. And we have 100 by 141 millimeters. That's the size of our piece of wood, if you remember. You can switch to inches if you'd rather work with inches, but I, like the rest of the world, like to use millimeters. And move along to the next step. Hit OK, and it opens up a nice representation of our block of wood. You can actually switch over to 2D, which isn't going to show anything right now because we haven't done anything yet, but all your modeling should be done, or sorry, switch over to 3D, but all your modeling should be done in 2D. So now we have to create our actual compartments that are going to be milled out here. There's more work involved than just creating shapes, but first we have to create the shapes before we do the rest of it. So there's this tool here under, if you see Assistant, there's tabs at the bottom. We got the Project, Assistant, and Tool Paths. So we go to Assistant, which opens up automatically when you start a new model. And you go to Create Rectangle under Vector Tools. So the width of our pinning track is going to be 6 millimeter because we have a 6 millimeter router bit. And the height is going to be 60 millimeter because that's the height that I worked out that I actually like, works for my design. As you can see, it pops up a 6 by 60 millimeter representation here. And if you have a smaller bit, if you're doing different sizing and stuff like that, and a smaller bit, and you want to round your corners, this is the corner radii, you can actually specify how many millimeters of roundness that you want on your corners. But because I'm doing a 6 mil channel with a 6 mil bit, those corners are going to be rounded automatically anyway because it's a round bit. So then we want to set our center point. So our center point is the actual center of this object that we're creating relative to the board. So it is 6 millimeters wide, and I like to have a 5 mil border on all 4 sides and between most of the parts. So if I'm going to be doing that, we've got and remember, it's the center, so half of 6 is 3, plus our 5 mil border is 8. So we're going to be in by 8. As you can see, it pops in 5 millimeters here. And then our Y. Everything centers from the bottom left corner here. So we want to center this on from the bottom. Remember, it's 60 millimeters tall. So you take half of that because it's center, which is 30, plus our 5 millimeter border, because I like to have a 5 millimeter border around everything, gives us 35. And you can see that it pops up 5 millimeters. So we're over 5 mil, we're up 5 mil, and then basically you just go create. And it has popped down, as you could probably see. I'll zoom in here. Oh, too far. There we go. And it's popped down a rectangle for us. So Now all that's left to do is, most of the work is done. We have our sizes set and we have our X and Y set. All you have to do is change the X to add more rectangles in a row here. To do that, we have a 6mm channel, and I want a 3mm spacing in between each channel. So 6 plus 3 is 9. So we just add 9 to 8, which is 17, and click on Create again. Now we get our next pin channel. Again, you just add 9 to 17, 26, Create. Add 9 to 26, 35, Create. Add 9 to that, 44. Create. Add 9 to that, 53. Create. Add 9 to that, 62. Create. 71. Create. And 80. Create. And that's as far as we're going to go with pin channels. It gives us 9 pin channels. So we can close this out. And you can see we have our 9 slots here. Remember, the bit is round, so these are actually going to be rounded on the edges, just like you saw the board that I showed you at the beginning of this video. So now what's left to do is create our little tool channels here for our top and side little tool areas. Again, we're going to create rectangle. The width, we're going to do the top one first. The width is going to be, it's 141 across, right? But we want a 5mm border on either side. So we just take 10 away from 141, because that's 131. And a height, well, you can figure it out depending on how much room you're using for your pinning channels and stuff. But we have a pin channel of 60mm, plus our 5mm on top and 5mm on bottom. That's 70. But I also want a 5mm space in between the little tool area and the pinning area, which gives us a total of 75. So out of 100, that leaves 25. So our height is going to be 25. And you can see our visual representation there. Do the same thing. Our center point, center of 141 is 70.5. And I realize this actually sounds complicated, but it's not really. Once you start working with vectors, images, and any kind of, like 3D printing is the same thing. When you start working with measurements, everything seems pretty obvious after a while. And then we have our Y dimensions, which is going to be 82, I believe. It is. So you can see that everything is set up properly. We have our 5mm on every side, which is what we want. And we just go create. And now that one is in there. You can zoom in and you can check it out that it's essentially it's on 95. Right there. And then you can zoom in more and actually see that it's on 5 here. But either way, the math works out, so you know it's right, but you can also zoom in and confirm it. But so we have our top tool tray, and now we need to do our side tool tray, and we just do it the same way. We go create rectangle. The width of this one, if you do the math, the width left over that we have, I want another 3mm spacing in between. Actually works out perfect because this ends at, the center is 80, so plus 3 because it's the center, it's 6mm, so the center of that is plus 3, 83. And then I want a 3mm border between that and the little tool compartment, so that means 86. And remember, this is 141, so that leaves us exactly 50 because our 5mm border on the other side. So our width is going to be 50. And our height is going to be the exact same as the pinning tray. The pins is going to be 60. So we have 50 by 60 parts area here. Our center point, well, I already know via math, and I've done it before, but you can do the math and figure it out. But the very center of this box is going to be 111. And if you don't like it, you can actually just play around with that number until it looks right on the screen. Or you can actually do the math like I did and realize that it is actually the center. And it's going to be 35, just like our pinning trays, our pinning channels. So there we go. We are in the right spot, and we can create. All right. So we have all of our boxes set here. Now, you can't just send this to the printer right now. It's not going to, or to the CNC machine right now. It's not going to do anything. What we have to do is create tool paths on all this. So you go on the bottom tabs here, you go to tool path, and we have a bunch of options in our 2D tool paths here. And what you're going to want is there are going to be different methods for clearing out each section. With the pinning trays, because they're only single pass, we can get away with 2D profiling. And that would be like, if I did 2D profiling on this box here, it would just cut out that box. It wouldn't do any of this inside stuff. It would just make a square on the board, and it wouldn't remove any of the inside. So because this is one pass, we can actually get away with our 2D profiling. So to do that, you just select all of these pinning channels. So you hold down Shift as you select each one of these. As you can see them turning purple or pink, purpley pink, fuchsia or whatever. So you got all 9 selected, and then we just click 2D profiling. And it'll pop up this box here. And it'll ask you, do you want to mill the inside or the outside of these lines? You want to mill the inside, because the outside would be ridiculous. Starting depth is 0, because the very top of the board is 0. It goes from the top down. So the very top of the board is 0, and our finishing depth is going to be 4 millimeters. So we're going these are the pinning trays. We're going 2.4 millimeters down. And this is, I worked out through testing and stuff like that. 2.4 millimeters seems to be optimal. All this other stuff you can leave stock. Allowance is normal, tolerance is normal, final pass thickness. You just leave all this stuff. Machine safe, you're probably going to want to set that. And the machine safe for my machine, and probably most machines, is going to be 2 millimeters. And that is, it says right there, it's the height that you want the tool to lift off the board in between movements. So not when it's milling. If it's going from one channel over to the other, you want it to be at least 2 millimeters off the board. And, 2 mil is safe, but you can change that to whatever you want. And our profiling tool, this is where you select the tool that you're going to use. As you see, I've got a bunch of stuff already set up. This is the one that I have set up. I just haven't renamed it yet, but it is set up for the 6 millimeter routing bit. As you can see, it's the tool diameter is 6 millimeter, and that's exactly how wide the routing bit is. And we have our step over, and step over means when it's in one spot and it goes, say it's clearing out a whole area, and it goes over to the next section, how far over you want it to go. If you went 6 millimeter, that would be like a whole new, like it wouldn't do any overlapping. So it'll mill a 6 millimeter channel, and then it'll step over 2 millimeters and then mill another 6 millimeter channel, which means it's only it's only milling out 2 millimeters on any consecutive passes, which is very safe for the tool and makes a better product. You don't want to do too much step over. You could do a 100% step over, which would be 6 millimeter, and it would go a lot quicker, but it wouldn't look as good, and it's harder on the tool. So a 2 millimeter step over, which is 30%, 33% of the tool, is pretty standard from what I found with all the tools that I've been working with. So 2 mil step over. Step down is actually how deep it's going to go on each pass when the tool goes down into the wood. How far down do you want it to go before it starts routing up or down? And with this machine and the tools that I use, 0.4 millimeter is as far down as I want to go with each pass. So each pass we're taking 0.4 millimeter depth away. Our spindle speed, 1000 RPM, that is the maximum speed of this machine. And our feed rate is actually how fast the head is going to move and remove material. 8 millimeters a second is about as fast as I want to go on this machine. You can go faster, but it's harder on the tool, and it doesn't look as good on the wood. And then our plunge rate. Our plunge rate is set to 1 millimeter, and the plunge rate is actually how fast it goes down into the wood, how fast your tool will go down into the wood. And 1 millimeter a second seems to be really good with the bit that I'm using right now. So that's the setup I have for the bit. I call it the 6.5 millimeter bullet. That's because I didn't change the name. This was actually another tool before, and I just edited the properties, and I just didn't change the name. Anyway, so we select the tool that we're going to use. After you set up your tool, you can, if you saw in there, you can go add tool and just create a whole tool, and you just basically you enter all those parameters. And if you're figuring new tools out, new bits out, you're going to have to play around with scraps of wood to figure out what the best properties are for your tool. But for me, it is all those things that I showed you for the router bit. So you select that, and then all this other stuff you can leave stock. You don't have to have your cut direction or anything like that on this tool. No ramping moves or sequencing or any of that stuff. You don't need to do any of that. We do need to set up our material, so we'll set up our material. And it is, the material I'm using is 13 millimeters thick. And then you can position 0 from the top or 0 from the bottom. 0 from the top, it just makes everything a lot easier. And basically we're ready to go create the toolpaths. So if I go create toolpath now, you can see that we have just a straight line down the center of each of these channels. And that is because it is a 6 millimeter bit and a 6 millimeter channel. So it only has to do one position. But it's going to do, like it does 0.4 at a time. So it's going to, you know, at 2.4 millimeters, you're talking like 6 passes or something like that to actually mill out one of these channels. So that is our pin channels. And now we are going to do our tool compartments here. So the same thing, you want to click on both of these, hold shift down to highlight them both. So you have our 2 boxes there, both turned pink or fuchsia. And this time we're going to use a different method, and this one's called area clearance. There are a bunch of other options here, the profiling options and path orders and inlay and all that stuff. And you can play with these too, but area clearance is what I actually want for our parts trays. And we have all the same options pretty much. We have our start depth, which is 0, our finish depth. I want these to be 4 mil deep. Leave all that stuff stock, our machine safe and everything. This is where we add our tool. So we add our tool. It's going to be using the same tool, the same 6 millimeter router bit, all the same stuff. When you set a tool up in the database, you don't have to constantly change it. So this is the same tool that we're using for the pinning channels, which is good. It means I don't have to stop the machine and recenter it and all that stuff. So we add our tool in there. And here you can actually fiddle with the tool options if you want, but I leave it all stock because I have it set the way I want it. With our step over 2 mil, our step down of 0.4, our feed rate of 8, plunge rate of 1, and our spindle speed of 1000. So another thing we got to do here is our tool clearance strategy. We want raster, which is good, but we want our angle to be 90. Because if you leave it at 0, it'll actually go horizontal. You want to go with the grain whenever you can. So if you change it to 90, it'll actually go vertical, which is with the grain. So we change that to 90. Our material is already set up, and everything's done. We just go create now. And as you can see, it put all the passes, all the pass information and stuff like that. Each one of those lines is a pass. And then, of course, we have a total depth of 4 millimeter with our step down rate of 0.4. So that means each one of those is 10 passes. So it'll go, it'll do a line here, move over, do a line there, move over, do a line there, move over, do a line there. It'll do all the way across. And then it'll come back to the start. It'll step down another 0.4 and do it all again. It'll do that 10 times until our channel is milled out on both of these. So basically we are set up now. There's nothing left to do except for save this. So you can go File, Save As. I'm going to replace this one. It's called YouTube PinTray.art, and that is what the program here saves the files as .art. And you want to save the toolpath as well. So you go Save Toolpath As. We want it to be an Anderson NNC, and that's the type of file that we send to the machine itself. And you want to add our toolpaths over. These are what we want to happen. And you can actually set the order and everything too. So if you want the pin trays to go first, which I do, you set your profile first, which is our pinning trays, and then our area clearance after, which is the parts areas. And then you just hit save. And again, we're going to overwrite. I've already done this, so we'll overwrite this one. Here's the YouTube PinTray.nnc. Save. We'll replace it. Now we can close everything out. All that's left to do now is calibrate the machine, load up the software, load up the program that actually runs the software, and we're good to go. So let me get all the lights back on. We'll set up this machine. I'll show you guys how to do that. Alright guys, so this is the program that we use for actually sending the work to the machine itself. It's called GRBL Control, or Gerbil Control. GRBL is the type of CNC machine this is. Most hobby ones are. And what we have here is, you can see there's all this step option and all of our stuff here that probably doesn't mean anything to anybody right now, but I'm going to explain it all to you. For example, this is moving. I don't know if you can hear the servo. That's actually moving the machine in the up and down. This is moving it left and right. And this is moving the platform back and forth. And this is actually turns the spindle on. So, as you can see here, we have our work coordinates and everything. And if you go down to the bottom of jog, there is an option for keyboard control. And what that means is you can use your keyboard numbers on the number pad to actually create movement on the machine. So that's what I use for calibrating. And what we have to do, let me get over here. What we have to do is actually center this bit, because remember the very bottom corner of this wood is 0, 0. So we have to actually get the center of this bit to 0, 0. And that's the center, absolute center of the bit, not just the edge of the bit, but the center of the bit. So let me see if I can I'll put this down somewhere where you guys can actually see the machine moving while I calibrate. You guys are going to have to do this if you ever CNC anything or mill anything. It's going to have to be centered like this. This isn't working out very well. There, that'll work. Perfect. So, basically I'm just playing with the arrow keys. And I have to bring this over to center on that bottom left corner. So that is as far as it goes. It is only 100 millimeter travel on this machine, so that is actually as far as it goes down. Don't have much of an option there. So we'll bring it down. Get as close as we can without touching. I think that's actually touching there. And it looks pretty close. I think I can go over. We can switch our units to It's set to 1 millimeter, so now I'm going to go to 0.1 millimeter movements. And it's going to be very minute movements right now. So that actually looks pretty center there. Alright, so what we have now is a machine that is centered on both axes, the very corner to the center of the bit. That as close as I can get it, because this the machine only goes so far on the y-axis, but that's fine because the board is actually cut a little big and I can clean the bottom up. So we pretty much have it zeroed now. So we go back to our software and you can see these options here. We can 0 XY, and if you see the numbers up here, our work coordinates, how they're all jumbled up right now, by 0 XY changes them all to 0. So as far as the machine knows, this is 0 0 right now. Now we have to do kind of the same thing for the spindle itself. So if you can see, it's almost touching. Let me get this back in the vise here. There we go. It's almost touching the wood. Let me focus in. There we go. So now what I do is I just take a ordinary sheet of paper and I want to bring this down until it actually binds on that sheet of paper. So it's still moving freely. Still moving freely. Starting to bind. It's totally bound now. So it's actually touching right now. And if I was to fire this up, it would actually start milling some of the wood away, which we don't want. So we're going to back it off one. And a little bit of friction there, but not a lot. So that's pretty much what you want. It's not actually touching the wood. So I can fire up this machine and not leave any marks on the wood. I'll test that now. And indeed it looks good. So let's move you back to the machine here. And again, our coordinates here are a little off here. We want to 0 the Z. So now everything is set to 0. The machine is ready to go. We have nothing loaded up right now, but as you can see, we have everything set right where we want it. It is set on the very bottom corner, ready to go. And now we will load up our program or file that we created. Open the desktop. What was it called? YouTube pin tray. Open. And there we go. As you can see, this is going to be the path that the machine will take. It's going to do all this stuff in pretty much the order it shows you, and it'll give you a visual representation of what's going on. So basically you just fire up the machine and you hit send. And you can see it's moving around. It does a little bit of moving around back and forth here, and we'll see our 1 millimeter plunge rate. Our 8 millimeter per second movement speed. Alright guys, so as you can see, it gives you a visual representation of what's going on the screen here. You can see what depth it's currently working at. So it just went down another 4.4 mil. You see our X and Y coordinates. And this will be the last pass on this channel. And it'll move over and it'll do the next channel now. So there we go. I'm going to let this go for a while, guys. I'll come in periodically and show you how it's doing. I usually just leave it, all the wood chips and stuff pile up, but I'll vacuum it off in between and show you guys how it's going. So I'll come back a couple times, but ultimately we just let this run now. So see you in a bit, guys. Alright guys, just going to clear this away a little bit. See how it's going so far. That's the step over we were talking about. So 2mm step over makes it really easy on the bit. Anyway, we'll come back as more is done. And it's done. So this is what we get when it's completed. It looks a little rough right now, but that's just because it lifts up all the fibers on the end here. Let's actually go back to our software here. As we can see, job completed. Took 1 hour and 44 minutes and 47 seconds. So pretty much an hour and 45 minutes. Let's move our head up, so we can get it out of there. Undo all our wing nuts here. And let me I'll just put this down for a sec. And let's get this in a tripod. All right. That is what it looks like right out of the mill. As you can see, everything is cut properly. And you really have to pay attention to your calibration. As you can see, it's over a little bit to the right, but that's fine. I leave a 5mm border so I can actually just take this to the sander and sand down the long side to match. So that's not a problem. It's probably only like a millimeter, maybe 2 out. So it does look a little rough right now, but all we have to do is hit this with some sandpaper. Let me set that up and I'll be right back. Hey guys, I'm just on a flat surface here. It's a very flat top of my shelf. And we have our rough, and you can see it's all pretty good, except for those little stringy pieces at the ends of our cuts. And those are actually really easy to get rid of. You just a little bit of sanding here. And as you can see, most of them came off with just that little bit of work. But we'll continue on. And every bit you do gets better and better. So you can also let's put it down and do it by hand. Let's get a little piece of sandpaper off of here. And just run it along the edge. And it cleans right up. This is just 600 grit sandpaper, but you can use 150 or 240 or pretty much whatever you have lying around that's not like 80 or less. So we can see it's already looking better. We spend a couple minutes here and we'll just touch up all these edges. Get rid of all these little strings. The hardest ones to get are going to be the ones at the top of the pin channels. And there's a way around that too. You just curve your sandpaper and get it in there and just give it a little bit of a roll. You can see number one is done. Let's do that for all of them. Takes a little bit, but that's done. It looks nice. So I'm going to continue on here. I'm going to do a little bit of cleaning, just getting those little fibers out of here. There we go. So you could spend a touch more time getting rid of all these rough edges, which I probably will before I varathane it. But as we can see, we've got a pretty nice looking pinning board. I'm going to have to, like I said, dress it on the sander. Going to have to take down this edge just a little bit. Maybe the bottom edge as well, because it looks a little thicker at the bottom than it is at the top, which isn't as big of an issue as the side. It does look a little offset. Should have gone over another millimeter or two to the right here, but that's why I leave the border, so it's easy to clean up. Also, I'm going to round the corners with a file or a piece of sandpaper or something like that. So I'm going to do that, and then we're going to look at etching the center of this tool tray here. But as you can see, everything looks good. Nice and tight lines, and measurements are all in the right areas. Everything is good. So, give me a couple minutes here, guys. I'll tidy this up and we'll be back to laser. Alright guys, we are all done with the sanding, and as you can see, very nicely finished. I've matched the right hand side with the left hand side. I've rounded all the corners and finished sanding all the tracks and stuff like that. All the strings and everything are gone. As we can see, nothing but nice lack of focus. Come on, focus. There we go. Nothing but a lot of nice milling here. Everything is good. So now it is time to laser etch this thing. Normally, if you were just gonna be done with it, you could give it a coat of varnish, but we are going to laser etch an emblem in this side parts tray here. And to do that, I'm going to get the camera set back up on the screen here, load up the software, show you the software portion of it, and then show you the hardware portion of it after. Give me a minute, guys, and I'll be right back. Alright guys, I've loaded up the laser burning software. It's called Lightfire. And this is the software that came with the machine, of course. And to use this, the first thing you have to do, and I've already done it, in the bottom corner, you have to set the work area. We're working on that parts tray, which we made, so we know it's 50 by 60. This is just the default image. It loads up. There's a bunch of ones in here. My two favorite. But so from here we have our image size selected. 50 by 60 is going to be our burn area, and then we load picture, and then we pick whatever image we're going to be using here. Let's go over to thumbnails. We better find what we're looking for. There we go. So, in this case, I am going to be burning this one for Bobby Keys. I don't know, next time we have a trade, or maybe I'll just send it to him out of the blue, but either way, this one's going to be for him. So, I'm going to load up that picture, and then we pick the best option here. You can see a lot of these are kind of grainy. I'm not sure how well that's showing up for you guys. Zoom in on this here. So you can see these first ones are really grainy, so you probably don't want those. And then this one's got a lot of background. These two have a lot of background stuff in there. And these two are probably the cleanest. But out of those two, this bottom one probably looks the best. At least it does to me. Not too sure if it shows up that well on the camera or not. But so you pick the best one, essentially. And then you center it in your area. And you can here go with your pixel size. So you can see that you can make it smaller, or this is actually as big as I can make it, so the biggest you can make it. And then you have your burning time, and the burning time is going to be how dark or deep you burn. I always like to have the maximum burning time. It takes a lot longer to actually get in there, but It makes for a lot nicer of an image. And then you got to crank up your detail. You can have your detail way down, but I like to have my detail way up to the top for detail. And that is going to be what we are burning in the side parts tray of this pinning tray. So we want to make sure it's pretty center. It's looking pretty good there. And then you can do things like invert the image. It could be cool, but I think it's better to just have it like so. You could also flip it for whatever reason. I don't know why. And all that other stuff. So from here, basically, the software is ready to go. All we have to do is hit start, and it'll actually start etching. But we, just like the router, we have to set this up properly. So we have to go over, calibrate the machine. I have to actually switch the spindle out for the laser itself, and then we have to calibrate the laser. So we're going to do all that now. Let me set up this camera over there, and we'll take a look. All right, guys, there's actually a couple things we have to do here. First thing we have to do is switch out the spindle, and I didn't show you installing it the first time, but it is really easy. This is just kind of a clamp held on by an Allen. So you just loosen up the Allen screw. I'm going to need it in a bit here, so I'll just put that down. Pull out your spindle, unplug it from the board. So it just plugs in nicely. Molex connector. Our spindle is unplugged. That is the bit I was using, the router bit. Standard router bit for a Dremel. And grab our laser, which I have in an anti-static bag just to keep all the sawdust away from it. The last thing you want to do is get a bunch of sawdust up in the laser here. So this is our laser module. It is 1/2 watt, which is really strong. It's less than that's what they're blinding the pilots with. So just to give you an example of how strong this laser actually is. So we'll get this in the holder here and tighten it down. That's how easy it is to switch between your spindle and your laser. Not hard at all. It's in there good. And of course we have to plug it into the right spot on the board. So let me get in here. Oops. Sorry, bumping the camera, guys. Okay, it's not supposed to be on right away, so I think I might have the wrong one here. Just going to move this camera for a sec, guys. Sorry about that, but it's right in my way. Got to be able to look back here. Still in my way. I think that's the right one. Well, one way to test it, get this wire out of the way so we don't burn it. And in the software itself, there's an option to turn the laser on, strong or weak. So we're going to go weak. There we go. Yeah, that is the right one. So now that we have the laser in there, and you can see that it is on, so we'll turn this on. Also, guys, you're going to want some laser glasses, so get some laser lenses there so you don't burn your eyes out while you're playing with these. We will turn it on, the laser on weak, And this is not even half of how bright the laser actually is, so it's not going to burn anything. It's just going to allow us to focus this laser. At the tip of this laser there's a threaded lens, and you can actually focus this laser. As you see, that's a wide focus. You want to tighten that beam down to where it's pretty small. But if you go too far, then it kind of diffracts, and you don't want to do that either. So you want it like right in the middle. And for me, I think it's about there. So I'm going to get a little bit closer to the product. So that looks pretty tight. So I'm just going to hit turn the weak off for a sec, and I'm going to turn the strong on for a sec, and we're going to see how it does. So you could probably see a little puff of smoke there, and our line, that dot, it's a little big. We want that dot to be as small as possible. And it's looking pretty good, actually. I'll give it one more test here. Yeah, that's looking pretty good. Our weak laser, strong laser. So as you can see, you can actually go pretty quick with this thing if you don't want to go too deep or dark. But we actually do want to go deep and dark. So let me turn that off. But as you can see, our laser is nicely calibrated. It's nice and fine. And the next thing we got to do is I'm going to take my burn time down a little bit, guys, because the longer it actually burns, the thicker it looks. So let's give this thing a test shot. It's good to have a piece of wood like this around. This is on weak. Stick it in the corner. And I'm just going to hit start on this program right now to just see. I have it about halfway on the burn time. Another thing I like to do is have a fan going in here just to blow the smoke away. But I won't do that until I actually start burning. And this is just one of my prototype pinning trays that I never ended up using. Never finished it or anything like that. So the depths are proper though, so don't have to worry about that. Alright. That should be enough to judge. That actually looks pretty good. So I'm going to leave it on half burn time because the actual resolution is a lot nicer. So anyway, now that we have it all set up, ready to go, Basically, we have to put our board on there, which I am going to keep down with a little piece of double-sided tape. So we got some double-sided Scotch tape. All this stuff takes time. Once you get used to doing it, it's not so bad. At first, it's a little daunting trying to figure all this stuff out. But once you do, it's totally worth it. So we'll get this on the tray. We'll make sure it's straight. Stick it down so it's not moving. Good. It is straight. And now to calibrate this thing, what we want to do is, remember, 0 is always the bottom left corner. So we're going to turn the laser on weak, and we're going to line it up to the very bottom left corner of that pinning tray. So our laser is on weak, and I'm just going to use the XY buttons here on the laser program to move it around. Wrong way. So that looks like it's pretty much on the corner. Move it down until it's on the corner. And that looks like our bottom left corner right there, guys. So you have to account for the contour there. So now basically you can, it's calibrated. You just turn the weak laser off. And we need to start. So I'm just going to turn the fan on. It helps clear the smoke out. I don't think it makes much of a difference, but you know, laser going through the smoke, it might cut down some of the actual strength of the laser. So. And there we go. I'm not going to show the whole thing because it probably does take about an hour, maybe more, to burn Bobby Key's logo on here. So I'll come back periodically through the process, just like I did with the milling itself, and we'll see how it's going. See you in a bit, guys. Yeah, our power just went out. So I was partial. Oh, I think the power just came back on. You can hear the generator or the breaker box just kicked back on. So that sucks. Yeah, this is pretty much a useless piece of wood now. I could try to calibrate it in the exact same spot. As you can see, we were almost on the bottom line of his logo there, and it was looking pretty good. It's not too deep. It looks like it is pretty deep, though. I might try to sand it out of there and try again. So let's give that a shot. I'm going to hit this with some sandpaper and see what happens. Hey guys, I somewhat lucked out. I was able to sand it off. It took, probably about 20 minutes of sanding to get it off. And of course I have to sand evenly everywhere because I don't want just a hole in the middle of this thing. So it did come out, but it took a good 20 minutes of sanding, and you know, just on the inside of this box, and my fingers are raw now. But I'm going to get this back up in the laser and give it another shot. Hopefully the power doesn't go out again. If it does, I probably won't take the time to sand it all again. I'll just use it as a personal pinning tray and try the whole thing all over again. But anyway, just goes to show you, when you're relying on technology to do this kind of stuff, even like when I was milling, if the power would have went out, that would have been it. You can't reposition this to have it exactly in the same place it was the time before. It's just not possible. It's within the fraction of a millimeter, and it's enough to throw everything out. So I'm going to get this back up. I'm going to turn the computer back on. Everything just shut right down. So I'm just going to get it all back up and start burning again. Alright guys, here we go. Attempt number 2. If it craps out this time, probably not much I can do about it. I'm not going to sit there for another 20 minutes sanding this thing. I'll probably just start again on a day where the power's not going out. It's funny because the power almost never goes out here, but in the last week it's gone out 3 times. So it is snowing outside right now, first time this year, so maybe had something to do with it. But anyway, I will keep you updated. Alright guys, here we are, 51 minutes in. As you can see, it's going pretty good. Power hasn't gone out again yet. We got a slight discoloration around the burn area, but a very light sanding will get rid of that. And I think that's the letting the smoke sit around there. I think that's just staining from the smoke. Anyway, almost done. Alright guys, I think it's coming to an end here. It has ended. So, let's see what we got. Keyboard out of the way. Looking pretty damn good. Not bad for power going out the first time around. So you can see there is a little bit of staining of the wood. But like I said, a quick light sand with some 600 should get rid of that. And then the next stage is going to be to get this with some lacquer thinner. And then Bob should be my uncle. Or Bob should have a printing tray or something like that. Anyway, guys, I'm going to give this thing a light sand and see how that works. Should be fine because it took a hell of a lot of sanding to get the first run that the power went out on out of there. It took like 20 minutes of sanding before it actually was able to disappear. So if I give it a nice light sanding, and that was with 150 grit, so if I give it a nice light sanding with 600, I should be able to get that little bit of staining out of there, no problem. And then a coat of Varathane. So I'll be right back. Alright guys, here we go. A little bit of sanding and most of that staining came out, so it should be pretty good now. What I have here is some Varathane. I believe this is from Minwax. It's actually Varathane brand, I guess. Anyway, it is high gloss, and this stuff, you got to stir it up a little bit. You don't want to mix it up too much because you don't want to put bubbles in it. So you don't want to go too fast, but basically you stir it around a bit, bring it up to the top, because it does settle a little bit. You don't want to shake it, and you don't want to stir too vigorously because you will introduce bubbles, and that will screw everything right up. As always, I keep a rag or a paper towel around here and a brush. So I'm just going to Varathane this thing, and you will see it come to life pretty much right in front of you as soon as you start spreading the Varathane on. This is supposed to be thin, so I'm going to have to spread this little bit that I have on the brush as far as I can on this pin tray here. The idea is to not get a huge coat on it so that it's like sheeny gloss, glassy. You want the first coat to be enough that it soaks up into the grain, and you get a decent coverage on the entire board. So as you can see, everything's kind of coming out on this board right now. The grain is starting to pop out. And you just gotta not use too much. So what I have on here right now is probably enough. I'm just gonna have to spread it around. You don't want it to pool up in those pin channels, so you have to go in there, pull it all out with the brush, brush it on other parts of the pinning tray until the brush dries out. Go back and get more. And you just work with little bits at a time. Gotta be careful to get all the nooks and crannies and corners and stuff. And this first coat is going to get soaked up quite a bit, which is kind of what you want. It enters into all the grain and pores of the wood and kind of seals it up. So when you go in for a second coat, the second coat actually sticks around. You just want to make sure that you get all the corners, all the sides. Sure, you guys don't need Varathane lessons, but this is how I do it. Some people go overboard with the Varathane. Takes weeks to dry, and you know, kind of never really sets properly. It gets a little tacky. Sometimes you get marks in it and stuff like that. So really, it even says on the bottle, like on the jar or tin, you're not supposed to use too much. You just use bare minimum. Spread it around. We're basically sealing the wood and popping the grain out is really all we're doing. As you can see, that looks like it was enough. Might need a tiny bit more, and we're talking like less than a drop. It's a little dry at the top here. There we go. So that is about it. I'm going to get the sides here because they are not done yet, but as you can see, that's what the wood looks like originally, and that's what they coat a Varathane. Looks a lot nicer. So I'm not going to bother doing the bottom because the bottom is where I put the felt. So I will do the sides. And the end grain especially, because that is where a lot of contamination can get in. When you buy a plank of wood, it's usually sealed on the end grain. That's for a couple of reasons, just to stop anything from getting in there, but also control the curing, the moisture loss of the wood. If you lose moisture too fast, it cracks. So you usually seal the end up to control the amount of moisture that can come out of the wood. Well, it's looking pretty good here. So I'll let this set for, I don't know, maybe an hour or two, and then I'll come back and give it one more coat, because 2 is usually good enough, I find. And even without touching the bottom, you can see it start to soak in to the edges here. It's very thin. A little bit goes a long way. All right. And with the brush, you can use a rag or paper towel. Because I never use much to begin with, I just brush the excess off on a paper towel until it stops coming off. And you don't have to clean this brush off or anything. It'll be good for the next time. Just don't leave any in there. Don't use a lot to begin with. And you're good to go. As you can see, it's not leaving any marks on the paper. So we are pretty clean. And we have one Bobby Keys pinning tray, made of poplar hardwood, and ready to put felt on the bottom once I get one more coat on here. But I'm not going to bother showing you guys that. You can figure out how to glue felt onto the bottom of a piece of wood. Anyway, guys, thanks for watching. Hope that lets you guys know exactly what's involved with making a pinning tray with the 1610 CNC router / laser. And if you have any questions that I didn't cover or need any clarification, just leave a comment below, and I'll be more than happy to let you know. Alright guys, later.